Okay, so like I said, so this is the last part of chapter 6. So we're gonna finish chapter 6 this week. When we get back from Thanksgiving, we'll review for a few days, and then group test, individual test will follow. But we'll definitely review the first couple days. I'm not going to give you a test the first day we're back. We'll review for like 2 days, do a full review of chapter 6, and then Wednesday will be the individual group test, and then Thursday and Friday will be the individual test. Okay, so yeah, that's what we're gonna do. So this week we're just gonna finish the content, finish the new stuff. Okay, so the last thing we got to talk about is something called geometric distribution. We've talked about binomial the last 2 days, right? Binomial the last 2 days. That's what your assignment on, the assignment I posted yesterday, that's what it's based on, binomial distribution. Okay, the other type of distribution besides normal distribution, which we've talked about before, is geometric. Okay, geometric is very similar to binomial. In fact, these are the conditions for binomial, right? These are the 4 conditions. We talked about this the last few days, right? Has to be binary, means only 2 options, success and failure. Independent, all observations, knowing the results of one observation tells you nothing about the next one, probability of the next. Has to be a fixed number of trials, and the probability of success always has to remain the same, right? Okay, that's for binomial. This is geometric. Binary is the same. So same binary, has to be 2 options, success and failure. Whatever success is, and then everything else failure. Has to be a failure. Independent is the same. Success at the bottom is the same. The only difference, the way you know it's geometric, is that they don't give you a fixed number of trials. It's go do what we've been doing until we get a success. Once we get a success, it's over. We stop. Okay? Like, let me go over like the ones we did the other day. Like questions we did, like this question here with the jury pool, the juries, females in the jury, right? We had a fixed number, right? 12. 12 was our fixed number. We stopped at 12. Can't go higher than 12, right? And then for this question here, for when we're rolling dice, 80 rolls. It says 80 rolls. We stopped, right? We didn't go over 80. There were fixed number for this one here, was 100. I think it was 100 tickets. 100 tickets they bought. Okay, that's where we stopped. Today we're not going to have that. Today they're not going to give us a stopping point. They're going to say, go until you get your first success. Go until you get your very, very first success. Once that happens, it's over. So it could be after the first time. It could be after the second time. It could be after the third time. It could be after the 50th time. We don't know. Okay. So the questions are a little bit different. All right. So we have a new formula. Now, these 2 formulas are not given to you. They're not given to you. And the reason they don't give you the formulas, like the ones we used the other day, right? These formulas here, all of these are going to be given to you. All of these are given to you on test day. Okay? But the reason they don't give you these is because it's kind of common sense. These are kind of common sense. First of all, this one looks, this guy right here, looks a lot like this guy here. Okay? This is the one you have in front of you. This is the one we were using the last 2 days. What's the difference? Exactly. This part here, right? This part right here is the difference, right? This part is the difference here. This is not there here. It's not there. There's a reason for that. Is because this part here was important because it told us how many ways down our tree diagram there were. This told us how many paths down our tree diagram give us an answer the one we want, right? Like when we did this question, review. I think we did this on Monday. We did this question on Monday when we figured out the probability, right? When we made this table here, we used the tree diagram, right? We made a tree diagram. And then we figured out, oh, okay, so how many makes, or so how many ways down the tree diagram is going to give me that, right? So we figured, okay, there's only one way to make all three. There's only one way to miss all three. But there's 1, 2, 3 ways to make only one. And then there's 1, 2, 3 ways to make 2, right? And that's how we figured out these percentages here, these decimals here, right? That's how we did that. Well, so this guy right here only has one way. There's only one way to make 0 makes. One way down the path here. It'd be 0, 0, 0. Right? Only one way to do 3, right? 3 makes. Make, make, make. Well, how many paths were there to make this? Why isn't it? Come on, come on, come on. There we go. How many ways is it to make this guy here? How many paths were there to make that? There were 3 paths, right? How many paths were there to make this guy here? There was another 3, right? 8 paths total. 1 here, 3 here, 3 here, and 1 here, right? That's what this part tells us. This part calculates how many paths down the tree diagram. Now, if you're only doing 3 shots, it's easy. But what if you're doing 20 shots? Do you want to make that tree diagram and then go figure out how many ways down the path I can? No, right? The tree diagram for 20 is going to be huge, right? So this is a quick way of doing it. It's there for binomial, but why is it not there for geometric? There's only one path. There's only one path that's going to give me fail, 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 success, right? Once we get success, we stop. There's only one path. So there is a number here. It's just 1. Okay? This part right here wasn't too bad. This part right here wasn't too bad, right? So really, if you have this equation here and it's geometric, just change that to a 1. It's a big 1. Okay? So really, they do give you the equation. You just got to know that. If you know what geometric is, you'll be like, oh, okay, I'm just going to use the binomial. I'm just going to change that to a 1 and plug it in. Okay? And then this guy here is expected value. So this, another way of saying this is, how many would I expect until I get my first success? So what's the probability that my first success will come after 4, after 5, after 6, after 7 attempts, whatever tries, right? So this is what we do here. 1 divided by the probability. Okay. All right, so let's look at a problem. Let's look at a problem here. So the first example. Suppose that Joanna is a salesperson at Macy's. Okay, recently she has been selling a pair of jeans to roughly 25% of the customers who try them on. This afternoon, she will have 20 customers trying on jeans. Okay. What is the probability that the third customer will be the first to buy? So that means the first person comes in, tries on the jeans. Nope, I don't want them. They don't buy them. The second person comes in. Nope, I don't want them. Didn't buy them. The third person comes in, tried them on. Yeah, I'll buy them. Right? So what's the probability that the first success is the third customer to come in? Now, why is this geometric and not? So why is this geometric distribution? I can't use the nice formulas I have unless I know it's geometric. What about it makes it geometric? Yeah, but we've been doing probabilities in chapter 2, chapter 5, chapter 6, right? We've been doing a lot of probability. So not necessarily probability, it's definitely a part of it, but we have normal distribution, binomial distribution, geometric distribution. What makes this problem say geometric probability? Because the question, exactly, the question is put to you, when will I have my first success? When will I have my first success? If that's the type of question you see, it's going to be geometric. Okay? It's not asking what's the probability that 8 out of the 20 people who try on jeans buy them. That's binomial. But when they say what's the probability that this is your first success? That's geometric. That's the difference between geometric and binomial. Because on the test today, I'm telling you right now, it's geometric, right? It's kind of obvious, right? The title of these notes are geometric distribution, right? So it doesn't take much brain power to know it's geometric. But on the test day, and this is where some of you got thrown off on chapter 5 test, you used rules from this section to do problems from this section, and then you kind of got turned around and you got the wrong answer. So on the test, I'm not going to tell you, is it geometric? Is it binomial? You have to kind of figure it out on your own. Okay? So I'm trying to give you some hints as to why is it geometric? So that if you see, because on the test, I'm going to give you a problem like this. And part A might be normal distribution. Part B might be binomial distribution. Part C might be a geometric distribution. And you're going to kind of have to figure out, okay, this one is normal distribution, so I'm going to make my curve, sketch it, do all that stuff. This one's binomial, I'm going to do binomial. The last one is geometric, so I'm going to do geometric, right? So I'm going to do that because I want to be able to tell if you know the difference, okay? So again, you're looking for little clues as to which path, which step am I going to take, okay? So the clue here is first success. When is you going to have her first success? So what is the probability that the third customer will be the first one to buy? Okay. So this one here, K is going to be 3 in this case because the third customer is the first success. Okay, so probability X equals 3. If the third customer is my first success, what happened before that? Failures, yeah. How many failures did I have? 2. There's only, if I were to make a huge tree diagram, there would only be one path that led me to fail, fail, success. There would only be one path. So that's why this part here is not there. This part here, NK, right? That's not there for geometric because there's only one path. So it's 1 times whatever, okay? So what's my probability of success? That's the first one. Success is the first one. 25%, right? That's success. Success means they try it on and I sell it. How many successes am I going to have? 1 success, right? How many failures am I going to have? No, I only did 3, right? Third customer. Yeah, see, this part kind of throws you off here. Some people look at this part and say, oh, it's binomial. It's a fixed number. Not for this question. This question is a geometric. So I'm going to have 2 failures on the first one. What's the probability of failure? And there you go. This one you can do on any basic calculator. You don't need a fancy calculator for this one. It's just 0.25 times 0.75 squared. That's the nice thing about geometric. Geometric, it's a lot easier to calculate. So 0.75 squared. So this is 0.25. This is going to be 0.5625. Okay. There's about a 14% chance. There's about a 14% chance that she gets success on the third one. Okay. About a 13% chance. Okay. That on the third person, that'll be her first success. What is the probability that it will take at least, okay, so now we're seeing one of our words that we've seen before, at least, right? 5 people to try on jeans to make her first success. So if at least 5 people try on her jeans, when's the first success? 6 is going to be the first one, right? Because if at least 5 people try on her jeans to make her first sale, well, actually, no, 5 will be it. Yeah, 5 will be it. So in other words, she's asking, what's the probability that the first person comes in, tries on the jeans, buys them? Plus, what's the probability that the second person comes in? So let's write this down. Let me write this down because it's a lot of things happening. So probability at least 5 people come in. So really, this is not going to be at least. Normally, at least means what? Greater than or equal to. But this is not going to be that way. This is actually going to be less than or equal to. Why is it going to be less than or equal to? Wait. What is the probability that it will take at least? Oh, okay, no. Still greater than or equal to. Yep. I read the problem wrong. Yep, sorry. Okay, so that means I got to find the probability that it takes 5 people plus the probability that it takes 6 people and onwards. And then where am I going to stop here? 20. I can't go over 20 because that's all they have. Let's say sometimes they won't give you a fixed number. Sometimes they won't give you that 20. If they don't give you that 20 and you're having to go, this is what you put. You just say, okay, whatever that number is, wherever I stop. Okay, but since they gave it to you, 20. Okay. So we're going to have to do this. We're going to have to do this same thing once, twice. Yeah, 14 extra times. Or we can use the calculator. This is where the calculator helps out with these types of problems. Okay. So okay, so we're going to go to the same place. We need distribution, right? It's a type of distribution. So to get there, we got to go to second vars. I'm going to scroll down until I get geometric. Now, is this going to be a PDF or CDF? CDF, because I'm adding. I'm adding for 5, I'm adding for 6, I'm adding for 7, I'm adding for 8, keep going until I get to 20. So I'm going to hit CDF. What's the probability of success here? 0.25. Here's a trick question. What's the X value?
4.
Good. 4. Because remember, it starts from 0 and goes up. Well, I want to start from 5 and go up. So my calculator can't do that, but I can go 0 to 4 and then subtract, right? Mm-hmm. Okay. So notice how this guy doesn't have an n in the front. Like binomial had 427. That was the last problem we did yesterday. 427, comma 32, comma 199, right? There is no n because there's not a fixed number of trials. Okay. Okay, so here we go. We got 0.62, or sorry, 68. 4. That's not my answer though, because we just talked about this. I got to subtract from 1 because that number is from 0. That number is 0, 1, 2, 3, and 4 added up. What's the probability? Or sorry, not 0, because it's not possible to have 0. You have to have at least one person come in. What's the probability the first person comes in buys? Plus, what's the probability the second person comes in buys? What's the probability the third person comes in buys? Plus, what's the probability the fourth person? All of 4 of those combined equal that probability there. I want everything else. So I'm going to subtract it from 1. 316. Okay. So again, this is why it's geometric. First sale. When do I get my first something or other? Sale or whatever you're talking about. Okay. Okay, letter C. How many people would she expect? How many people on a given day, how many people should she expect it takes in order for her to get her first? When is she going to make her first sale? Well, this word right here.
Expect.
There you go. Expect should tell you I'm going to use the mean. Okay. 1 divided by the probability. Mm-hmm. So 4 people. So I would expect the 4th person to buy. That's where the bar is the highest.
We expect to try on before they buy. Wouldn't it be the...
How many people we expect to try on before they buy?
So 4 people try on.
So the 4th person.
Oh, it's the 4th person.
This is the 4th person right here.
So are you saying 4 people try on, then the 5th guy, or is it the 4th person?
So if this is the 4th person, how many people would we expect to try on? 4.
Would be the first one.
Okay, so if the 4th person's the first one to buy, what happened in the 3 times before?
None of them bought.
How many people tried on?
4. Okay.
That's what it means. So that 4th person still tried it on, but they bought it. That was the difference between the other 3. How many people would we expect to try on jeans before they buy? The 4th person who tries them on bought. 1 divided by 0.25. So you go 1 divided by 0.25. 4.
Oh, right.
Mm-hmm. Okay.
And it's not always going to be a whole number. Or with geometric, will it always be a whole number?
It might be a decimal. Yeah, it might be a decimal. Mm-hmm. Remember, yeah, always. So calculate the number And then if it is a decimal, you can say 4 or 5. So let's say this number, let's say if I calculated it and I got this number, you know what, I should probably do this. Four people will try on jeans before buying. Right? In words is kind of putting it in plain English. If that number was 4.6, we would say 4 or 5. I would expect the fourth or fifth person to buy. Right? So if we calculate the number, you can kind of round in your explanation to make it a little more relatable, because you can't assume that the person who's reading your answer knows anything about statistics, knows anything about geometric distribution. They know what that means, though. If you say, oh, about 4 or 5 people will come in before they buy, anyone understands that. You don't have to be an expert in statistics to understand that, right? So they can check your answer and they'll be like, oh, okay, check. And then, oh, that makes sense. Okay. All right. Okay, so now I want you to try the next one, the Australian lottery again. So work on that one. I'll give you about 5 minutes or so, and then we'll come back and we will see what you guys come up with. Mm-hmm. Okay, so you go distribution, 0, CDF, right? So probability, let me do it up here. Probability of success is 25%, just like the last one. Second, this is a CDF, probability of success. Actually, it's the same exact input as the last one. 25% success, 4, because we want 5 going on, right? We want 5 going on. Same. 4. So 1 minus that. 0.316. How do I put that in context? Yep. Chances it's going to take at least 5 tickets to get a winner. 0.316 or 31.6%. Okay. So notice here, they didn't say how many tickets he's going to buy. They didn't say in this question, he's going to buy 100 tickets. He's going to buy 50 tickets. It didn't say. It just said he's going to keep buying tickets until he gets a winner. So for here, I put X equals K, because whenever that happens, we'll stop. I don't know when it's going to happen, but whenever it happens, we'll stop. Okay. All right. So let's see. Last thing we'll do for today, do the next example. Overweight Americans. Okay. So A, B, do A, B, C, and D.
Isn't that low?
Huh? Yes.
I feel like that's weird.
Okay.
Hey, isn't A and B the same question?